All right, so in this video, we're going to solve fourth degree equations, okay? Fourth degree, meaning x to the fourth is our leading term of a quadratic type, okay? We're going to try factoring. If not, we're going to use the quadratic formula, but there's might be some weird things that happen here. So as we learned previously in this unit, there are times where it actually benefits you to use easier terms, okay? So we're going to replace x squared with u. Okay, so if x squared is equal to u, then x to the fourth would be equal to u squared. Okay, x squared would be u, and we don't have to do anything with the 12 because there's no x squared there. So I'm going to rewrite this fourth degree equation as a second degree equation. Okay, so u squared plus u minus 12 equals 0. Okay, so we've turned it into a quadratic equation for now. But remember, we're solving a fourth degree equation, so we're going to have to go back and do something at the end. We're going to have to undo this, this part right here, okay? So we can factor this. U squared plus u minus 12 is u plus 4 times u minus 3. Okay, zero product property, set both these factors equal to 0. So we get u equals negative 4, and we get u equals positive 3, okay? So now then, I've got to go back and substitute. Wherever I see a u, I can resubstitute back in x squared, okay? So here I get x squared equals negative 4. So when I take the square root of both sides, I get plus or minus 2i. So that's two of my solutions, okay? They're imaginary, they're complex, whatever you want to call that, but these are two solutions. If you plug positive 2i here and here, you're going to see that it's true, that that is a solution. If you plug in negative 2i here and here, you're going to see that it's true, okay? So these are two of my solutions. They happen to be imaginary. Now, when I plug in x squared here for u, I get x squared equals positive 3. When I take the square root of both sides, I can't simplify that any. So my last two solutions are going to be plus or minus radical 3, okay? So if you plug in radical 3 here, okay, you get 9. If you plug in radical 3 here, you get 3. 9 plus 3 is 12. 12 minus 12 is 0, okay? If you plug in negative radical 3, you get exactly the same thing. You get 9 plus 3 minus 12 equals 0, which is true, okay? So fourth degree equations can have at most 4 solutions, just like quadratic or second degree equations can have at most 2 solutions, and linear equations can have at most 1 solution, okay? Except for those linear equations that every number works. That's a unique situation, okay? So that's how we're going to solve fourth degree equations of a quadratic nature. Now in this one we could factor. In B you can factor also. I'm not going to do this example in the video here because I want to save some time. So let's move on down to C. Now once I let u equal to x squared and I replace everything here, I get u squared minus 8u plus 8. So this one can't be factored. Okay, so I'm going to be forced to use the quadratic formula here in a second, okay? So a equals 1, b equals negative 8, c equals positive 8, okay? You should be good with quadratic formula now. Shouldn't be an issue. So when I plug everything in, I get the opposite of b, plus or minus b squared minus 4ac over 2a, okay? When I simplify everything, that gives me 8 plus or minus 32, square root of 32, over 2. Now 32 can be simplified a little bit. 32 is 16 times 2. Okay, so that's going to simplify to 4 radical 2. Okay, notice everything here is divisible by 2. So 8 divided by 2 is 4. 4 divided by 2 is 2. So u equals 4 plus or minus 2 radical 2. Okay, remember I'm solving for x though. I'm not solving for u. So I'm going to go back and I'm going to substitute x squared in here. Okay, and this is where it gets a little weird and a little tricky. I'm going to take the square root of both sides. Okay, so that gives me x equals plus or minus the square root of 4 plus or minus 2 radical 2. So this is a really funky looking answer here, right? Okay, this represents 4 solutions. Okay, so we're going to break it down, the plus or minus and this plus or minus, to show all 4 solutions, okay? So let's assume first that both these are positive, okay? So I've got a positive out front, and I've got a positive in here. Okay, so it's positive square root of 4 plus 2 radical 2. All right, so this is an exact answer. We could stop here. I do want to approximate that. If you use a calculator, you can approximate that to about 2.61. Okay, so that's one of the exact solutions. This is one of the approximate solutions. Now, let's stick with it being positive out front, but let's change it to a negative in here. So my second solution is going to be x equals negative square root of 4 plus 2 radical 2. Okay? So when I evaluate that using the calculator, I get the opposite, which should make sense. So it's about negative 2.61. Okay, so that's two of my solutions so far. Okay? If you plug these values into the original equation, you're not going to get it exactly equal to 0, but it's going to be very close. It's going to be like 0.0001, or it's going to be negative 0.0001, or something like that. Okay? But it's going to be really close to 0. But because we rounded, it won't be exactly 0. Okay? So far we've dealt with both instances out here with positive values inside. Notice both these were positive. So now we're going to do where both these are negative. So let's say we have a negative out front and a positive out front and a negative inside. Okay, so I've got a positive out front and a negative inside. Okay, so that would be my third exact answer. If I evaluate that with a calculator, I get approximately 1.08. Okay, and then the last solution is going to be where both signs are negative. The sign out front is negative. The sign inside is negative, so I get negative square root of 4 minus 2 radical 2. Okay, it should be the opposite of this. Try it on a calculator. You should get negative 1.08. Okay, so notice all the combinations. Both signs are positive. First sign's negative, second sign's positive. First sign's positive, second sign's negative, and then both signs are negative. Okay, I have to count for all 4 of those because I've got a plus or minus here and a plus or minus here. Okay. Pretty unique situation. In this video, we're only dealing with 4th degree equations of a quadratic type, but you could do this with basically any degree out here as long as it's of a quadratic type. You can use this process to solve those equations. Okay? Just make sure you get all the possible solutions that exist for a given equation.